Hey, good morning, everyone, or good whatever time it is. Thank you for inviting me. Um, like, I'm very excited to give a talk in the morning. Like, that's the main reason I'm here, and I've experienced that. So, and that's cool. I like it. So, yeah, HTML WebSockets. Vladimir from Evil Martians. Sorry. Mm, just a second. Something wrong with my keynote. Okay. Yeah. No, it works. So yeah, you maybe saw my work at GitHub a little bit, like any cable already mentioned by Gennady, testprof, action policy, Ruby Banitsa, whatever. I'm mostly writing Ruby these days and also Golang, but I'm not going to talk about it today, so it doesn't matter. I'm going to talk about, you don't see slides changing, right?
We do. I saw like the coding, the Evil Martian.
Oh, okay. I can just hide Zoom for some reason. I don't see a part of the page. Okay, so we're going to talk about web applications. To make it easier to discuss the topic of the day, I'd like to think about web applications as simple as of two big parts. Like we have data and we have a representation, like user interface, which is what users see, interact with. So that's a web application. The data is somewhere, and there is a process of transforming this data into a user-friendly format. And we're going to talk about about a particular way of like doing this transformation. But before we start, I'd like to draw an analogy, and it's going to be like breakfast-related analogy. So breakfast is kind of similar. We have ingredients, it's our data, and we have a final plate, final dish. It's our representation. And if we'd like to, like, yeah, sometimes it could be just veggie if you prefer that way. And I'd like to consider different ways of delivering the representation, the food to users, or like getting a food. And I'm not considering cooking ourselves, like taking ingredients and like just going and cook it on the stove, because that would be not a web application with two parts playing back end and front end, but just a like one end application, like mobile game app or whatever, or just a game. And we're talking about web applications, so we always have two bodies. And there are different ways of getting ready to eat food from ingredients when you're end user or developer. So there is a canteen style way of things. That is kind of ready-made. We have a fixed and predefined set of meals. We have to wait in line usually, but it's cheaper than other ways. It's kind of simple food, nothing fancy, and it just works. It does what it should do. And we talk about web applications back. They're going to be more like a classic Rails approach, because the client get the ready-made HTML, now need to like do something with it to do some front-end stuff. We still have predefined set of roles. We have request queuing, and it's the easiest way to build a Rails application because it's everything you need for that is out of the box. That's a classic Rails way. That's one of the options. That's kind of old options, and in web applications, not a lot of people do it this way nowadays. And we have on the other side, we have like do-it-yourself experience, like Korean barbecue, Japanese, I forgot the name of cooking meat on the table. So the client get the raw food, but it also get the special equipment to cook this food. It's kind of expensive, especially for those who like build this kind of restaurants, because you need an equipment, you need to like good food and whatever. And that's more like building SPAs actually, because we push raw data to the client and client does all the stuff to make a meal out of it, to make an HTML out of it, because the end users like me sitting on the at the laptop, I don't care about what's inside the web page. I only care about the HTML and how it looks in the browser, and that's the final meal. And of course, this approach, building SPAs with backend in a different language, usually like we're talking about Ruby and Rails today, is much more expensive than like classic Rails approach, where everything could be done by one person who just graduated from the Rails bootcamp. But in reality, so there is something in the middle, of course, and that's a classic a la carte restaurants or cafes, where we have waiters who serve us concurrently. Like that's a real example of concurrency in real life, is a waiter in the restaurant, because he serves multiple clients at the same time. So you order once, but then you get food in batches without re-requesting it. Like that's a asynchronous communication. You even in a good restaurants, a server could refill your drink, for example, without asking you. So like that's something like push from the server, and everything is controlled. I mean, the quality of food is controlled by the chef, not by you, like in case of DIY, because you're cooking and you could spoil it. And that's actually what's I think is pretty close to HTML-over-WebSockets, because everything is controlled by the server. First of all, we have live updates, we have asynchronous communication, we have concurrency and all that stuff. And clients should not do anything. They just wait for the mail to come and consume it. And in HTML-over-WebSockets client side, all clients should do, like JavaScript client or whatever, is to get this HTML and put it on the page in the right place. That's it, nothing else. No need to build it, to render it or whatever. So that's a quick overview, just to warm up. What we're going to talk about, what's the difference between other ways of doing things. And the question I'd like to talk about in more details is whether this approach is possible, is viable in today, like in 2021 or maybe tomorrow. So can we really serve HTML over WebSockets and make it fast, make it interactive, and so on and so forth? And the short answer is yes. The longer answer you can find in my recent RailsConf talk, which is more about different ways of building modern full-stack Rails applications without front-end hell. And if you don't want to watch it, the recording in a week, yeah, like less than in a week, I'm going to represent it live at another conference called EMEA on Rails. So just remember the date, and there are going to be a lot of talks from the RailsConf. That's a special conference which just cherry-picked some talks from the RailsConf to present them live for the audience at this part of the planet. So HTML over WebSockets. The goal of today's talk is just to provide you an overview of architectures used to build such applications, which used by frameworks. I'm not going to like give you a fish to show you pros and cons, when to use this approach or not, and so on and so forth. I want to give you a fish and pole to demonstrate you how they work internally, so you can decide whether this approach fits you, whether it hides some pitfalls or whatever. And so that's technical presentation from this point on. And I would like to start with talking about not Ruby, but Elixir, because that's when this hype started, actually. Even though serving HTML over WebSockets is as old as Erlang, Nitrogen, and M2O frameworks, if whoever's heard about it, like it's 10 years ago, that always also was possible, but yeah, still no one used Erlang. Elixir made it, like at least made other people aware of this approach, because even though not so many people use Phoenix, really not so many, but we all follow its updates. We all watch its evolution, like, you know, it's like a framework of a dream, but for some reason we still write Ruby and Rails. And the announcement of Phoenix LiveView was something really new, like new air. It was amazing. Like, you don't need JavaScript to build all the interactive stuff. Wow. And how does it do that? There are three components of this. First idea that live HTML element, so they call it a live element, connects to an Erlang process. So there is a one-to-one correspondence between an entity on the server, which is a process in terms of Erlang, which is kind of like an actor model, right? So it's kind of similar to routines in Erlang, and not similar at all to threads and Ruby, but anyway. And then all the communication, all the user interactions are proxied to this Erlang process, and it does the stuff, like it recalculates the internal state, it sends back the updated HTML. And on the client side, they also use the morphdom library to perform faster incremental HTML updates. So how can you update HTML on the page? You can just replace inner HTML. But that's, first of all, there is a lot of update for large components. And secondly, you lose some browser-specific information like focus, caret position, and so on. With morphdom, you don't have all of this, and it's much faster. So that's good. So because we want this experience of sending it, like with SPA application, in many cases, you don't need to go to the server to get data, right? Everything is happening locally and it's blazingly fast. We can't beat that, but we can make communication super fast, even with network. And for that, we need sets tricks like morphdom, like WebSockets, actually. Why we use WebSocket and not Ajax, just because the round trip is overhead is much smaller. So let's take a deeper look at the LiveView and how it works. So we have a browser and a server. And whenever we render a live element on a page, it's connected to the server and creates an Erlang process responsible for handling the state and all the interactions for this DOM element. Then browser events are broadcasted to this process, and it sends the partial HTML template back to it. We're going to talk about this partial thing a bit later because it's very interesting. It also aims to reduce bandwidth. What's cool about this approach, and actually that's easy to do in Erlang than in other environments, that we also can react to internal system events the same way. Like this Erlang process, our violet one, which is responsible for DOM element, can also subscribe to some other events like push notifications from other systems, like other user events, like publish subscribe stuff. And it all handled by this process and broadcasted to the DOM. That's where LiveView actually differs from everything else we have in this talk later, everything else we have in Ruby. Yeah, and the same happens for every DOM element, for every browser, if we can draw more browsers on this page. Partial HTML updates. So imagine we have this template, which is like, I forgot to add a picture here, but that's just one item of the to-do list. So it could be checked, completed, or not checked, and that happens interactively. So it has kind of two states and some dynamic parts in the HTML. So what Jose Olim came up for LiveView, not Jose Olim. Okay, no, maybe I'm mistaken. I forgot who's the actual author of LiveView's templating, but that's a cool idea. We can, using simplest templates like ERB, but in Elixir, we can automatically, during the compile time, detect which parts are dynamic and static. So, and to send updates to the client, we actually only need to send updated dynamic parts. So we do not send the actual HTML to the client whenever something changes. We just send the updated dynamic stuff it has inside, and that drastically reduces the amount of data we send from server to client. Again, for the sake of performance. That's a brilliant idea, and that's something we still need to implement in Ruby frameworks. So just to recap, that's the final slide about Elixir, and everything else going to be about Ruby. Phoenix LiveView falls has some built on 3 pillars. First, it's component-driven architecture, actually, because each element is a component. It has its representation on the server, and that's an important thing here. That changed the way we write HTML views, actually. It's heavily reliant on our ecosystem to be performant and to provide real-time and one-to-many communications, many-to-many, and so on. And yeah, templating, dedicated templating mechanism is one of the important things here there. But let's come back to Ruby. So what do we have in the Ruby world? I decided to go in chronologically. So the first thing which appeared in the Ruby world, which usually could be referred to as LiveView for Rails, is stimulus reflex. Just to first thing I would like to tell you, it's not LiveView at all. There is almost no similarities, except from one thing, probably they both use morphdom, but everything else is pretty different. And I want to show you why. What's the difference here? Just some historical recap. Actually, LiveView is pretty much the same old as CableReady, even a bit younger. And CableReady is a crucial part of the stimulus reflex. And I would like to talk about this CableReady library first. So CableReady is a library to broadcast DOM update manipulation operations from server to browser. Currently, it's used Action Cable, so it was born in the Rails project, so it's kind of coupled with Rails today, but it's going to change in the future, and use morphdom. Quick example. Actually, the same example we had for Elixir, our item, HTML, and we use here remote through Rails, UJS stuff to perform an AJAX request. And the actual interesting thing happens here. In our controller, we use CableReady stream, which is just a helper for to identify a particular stream of updates for this particular item. And we call remove selector something like this. It's just kind of Ruby, some comments, some yet another DSL to learn, but that's pretty much the same as we did with JavaScript templates back in the days. But instead of writing JavaScript, we have a declarative approach. We have a predefined set of operations, and we use them. We don't need to write JavaScript for that to handle. Everything is handled by this library. So that's not that far from what we have in classic Rails, except from we don't need to write JavaScript at all, and we use WebSockets. That's the main difference. And as of today, there are 35 different operations we can use this way, and they all just work. And then the future version of CableReady, they're all actually going to be custom operations. You can register your own operation both on the client and on the server and use it. So it's kind of extensible as hell. And there are also some other interesting stuff which don't really matter for now. So let's back to stimulus reflex. So stimulus reflex is a combination of 2 ideas. First of all, it's the same CableReady which is used to deliver HTML to clients, update the DOM. So nothing changes here. The changes on the other direction. So we also need to handle user interactions somehow. So if we explain CableReady, we used AJAX requests. Now we can use the same WebSockets. And to handle these events, we use reflexes. Reflexes is a special Ruby class which respond to some pre-registered actions like RPC. The actual diagram of how stimulus reflex works is pretty huge. I'm not sure even if it's like up to date because it's like half a year old. I guess something changed since then because the framework is evolving fast. But if we want to go through all these steps, we will probably spend 5 or 6 meetups. And I don't want to do that. I tried to simplify things using the same approach we had before. So we have a DOM element. Nothing changed here. Whenever a browser event occurs, we send a message containing reflex class name and an action to the server through WebSockets. So there is a reflex class. We instantiate the class, call the action, and usually the result of calling this action is some CableReady operation or many operations. And the difference here, like, it's a subtle difference because the green arrow goes not back to the element, but to the whole document. That's because CableReady operation actually does not operate on the particular element. It's not scoped. You can send update to any part of the page, to the whole page even. Actually, and originally prior to version 3.3, like just a year ago, stimulus reflex always re-rendered the whole page, not re-rendered, but send back the whole page HTML, only the body part without layouts. But anyway, and then morphdom did the trick to update the required parts, like Turbolinks actually, right? So something like Turbolinks does with AJAX, but with WebSockets and a bit more optimized. Now it's possible to update particular elements, but still there is no one-to-one correspondence because reflex classes do not know anything about particular DOM elements. So you have to do it yourself. And if you want to broadcast data from anywhere else, you can only use CableReady and action cable from any other part of your application. So like background job or whatever. Any other client also use the same reflex class. So that's just to demonstrate there's no one-to-one correspondence. Let's take a look at the code example. So, sorry, the video has some sound on it. That's a simple application built with CableReady and stimulus reflex. So that's a to-do list which is synchronized between 2 different users. And there's not a lot of things we need to change in our non-real-time, non-interactive applications to accomplish that. To activate reflexing at the HTML side, we use data attributes. For example, here it's data reflex event name, then it comes to class name and the method name. One of the reasons there are data attributes is actually that's approach borrowed from Stimulus.js, and stimulus reflex is called stimulus reflex just because it's front end built on top of stimulus. So there is actually a stimulus controller which initializes the connection and subscription and handles the events. Then at the Ruby side, we have a reflex class. So that's a new entity for our application. That's a new abstraction layer we need to care about. And it has methods and some specific stuff, like we can use CableReady as previously in controller, nothing changes here. And we have morph methods. Like morph flash here is an updating flash alert on the page. So we are not only broadcast an update for the particular DOM element, we can also update something else, but for this particular user. So that's where CableReady differs from like LiveView because it's scoped to one element. Here we can just control all the page from any reflex. Whether it's good or bad, I don't know. Like that's up to you, because having full control of everything on the page is powerful, but it requires some like responsibility to carry that power. So that's the biggest difference here. You can build something like component approach with streamer reflex, of course. And there is also view component reflex library, which tries to do that. But out of the box, it doesn't have these limitations. It's fully unlimited to anything you want to do. But good thing about streamer reflex is it's really like stable and with good documentation and very active community. So whenever you have a question regarding stimulus, HTML-over-WebSockets of any kind or whatever, like go to Discord community, Discord of Stimulus Reflex, which will likely help you to figure out your struggles. Yeah, and it works with any cable, because like if it didn't work with any cable, I would probably not talk about it. Because why? And this year is gonna be a year of Stimulus Reflex new major version, which aims to become transport agnostic. So currently it's too railsy, it's action cable only, and so it's not usable outside of Rails. And the goal is to make it independent and to, first of all, to abstract the transport layer. And there are some thoughts on making updates reliable, because action cable is not a reliable connection, but that's a huge topic on itself. Let's move to the next thing, probably more expected than others, Hotwire. Well, I guess you saw a video or two from the recent RailsConf, because there were 5 talks on Hotwire, like 5 talks on Hotwire. That's wow. Not all of them were fully dedicated to Hotwire, but anyway, that means that's something cool. So this new magic came from Haycom, like Basecamp mailing servers. So, and it's gonna be included as a default gem into Rails 7. So you probably have to remove it from the gem file. I don't want to recall my own writing regarding Hotwire, which was released recently and goes in details and some ideas how to use it and not use it. There is also a cool talk. One of these 5 talks on Hotwire I would like to point to if you want to learn about the framework is a talk from Jamie Gaskin's Hotwire Demystified. So especially the last part, which discuss the trade-offs of this approach. That's pretty interesting. But let's recall what Hotwire is. First of all, Hotwire is actually Turbolinks, which are now called TurboDrive. So nothing changed here. Well, actually, internal implementation changed, but like from the user experience, you only need to change data turbolinks attributes to data turbo, and that's it. And you think turbo frames, it's like a scoped turbolinks. So previously turbolinks updated the whole page. Now you can wrap a part of the DOM tree into turbo frame element, and the click hijacking form submissions would work just within this DOM subtree, and that's going to be updating only this part. That's actually cool stuff. I really like it. So that's something I would like to use more. It also allows lazy loading of page parts. So you can, for example, split your page into static and dynamic, you get it, like in Phoenix, but for the initial page, and make dynamic parts lazy loaded frames, and cache the static part and serve it fast. So here is this quick example of TurboFrame. So we have the same to-do application, and we have update and destroy actions. But instead of responding with JSON or sending HTML over WebSocket updates, we just render a partial here. And when this partial arrives at the browser, it replaces the previous contents because it's going to be intercepted by the TurboFrame and its functionality. So all we need to do HTML side is to add a wrapping element with TurboFrame tag with a unique identifier, so it could be found on the page. And the final part of this stack, like this part of the Hotwire stack, because it's just a part of Hotwire, this turbo part, is its streams, turbo streams. Technically, turbo streams also provide a declarative way of updating the DOM, but unlike CableReady, there are only 5 actions: append, prepend, replace, and 2 others. So it's kind of transfer agnostic by design, because the turbo stream itself has no notion of transfer. And the good part of its integration with Rails, it's zero JavaScript, because it uses custom HTML elements to subscribe and trigger updates. So let's see how. So again, we have a browser, we have a server. And to initialize a stream subscription, we add a specific turbo stream source element on the page. That's a custom element, which uses custom elements API. Whenever this element get mounted on the page, it performs subscription to action cable and destroy itself. So user never see it. So it's not a part of the DOM. It's like the whole idea of turbo streams is to use this ephemeral elements which acts actually like actions. You add something on the page, it initializes and performs something and self-destruct. So that's how streams work. And probably frames work the same, but no, frames, no. I forgot, sorry. Probably frames still work like turbolinks, and fragment parsing is happening in JavaScript. But streams work like this. So we have a connection. Now we subscribe to updates. Then we do some action. So turbo streams do not have the other direction anything for you. Like Stimulus Reflex has reflexes to handle actions, but turbo streams, frames, whatever, do not. So you still have to use your AJAX request or whatever, like Rails Vue.js. So you perform a typical HTTP request, and you handle it in Rails controller. And then in this Rails controller, you can respond with a turbo stream element, which in its turn also is a self-destructive element, which contains an HTML and an action name, which must be performed, whether it's append, prepend, destroy, replace, whatever. The same could be done through action cable. You can broadcast change from anywhere, and it's going to be handled with turbo stream. With this subscription we created with turbo stream source. So this subscription just adds an element to the page, and whenever this element is added, it's again self-destructed and do some DOM update. So that's how turbo streams work. And that's cool because turbo streams doesn't know anything about how you deliver these elements on the page. That's why it's transport agnostic by design. You can use pretty much anything to put these elements on the page. That's how we subscribe. So in Rails, we just have a helper. That's all you need to start consuming updates for this stream, for this element. And then in your controller, for example, you do this. That's pretty verbose because like the stream channel name is long, the broadcast append to, and you specify a target, a partial, a locals, but that's resulted in sending this turbo stream element HTML to this turbo stream channel and adding it to the page. So Turbo Hotwire is a very Railsy way of doing this stuff. It's very simple for the end user, and it hides all the complexity inside as much as possible, like typical Rails way, which is called magic. There is no magic, but that's a good API design actually, which hides all the necessary things for the end user. There are more stuff we have for sending HTML or WebSockets in Ruby world. So like at least 2 more library I am aware of. First one is Motion. Motion is built with two things in mind. Let's use view components. And it's also Rails-C, so action cable. But the main idea here that it's component driven. There is no way to escape from the component when you update something. So you just have a component, it kind of a live component, and just that's it. You handle actions on the client side, re-render and send back. So that's pretty much like LiveView, but without super optimizations. And it keeps a lot of state in the Ruby side. What good about stimulus effects approach, actually? There is no client representation, like DOM representation at the server level, because server doesn't keep track of all the elements. It has reflexes, which are ephemeral, like RPC. And when you use components, you move state to the server and you store it there. And that has some side effects, for example, like memory usage, especially that's very crucial for Ruby, because like it's easier to keep active record objects in memory for all the connected clients. Like, why not? And that would blow your web server, blow its memory, like you're gonna die. Life is a very new stuff by Samuel Williams, who is the author of all this async stuff in Ruby. And it also kind of component driven. It's currently it's very early stage, but it already works, and it has minimal functionality, and it uses the concept of live views. You can even render from there using some kind of rendering mechanism. So it's again looks like LiveView, and like I think the plan is to be something like that with synchronous communication and publish subscribe within the server. But again, it stores the state at the server side. So yeah, nothing fancy here. So just everything is controlled by server. You don't even need to write any JavaScript code or manual subscribing to the server. Just rendering an element is enough to subscribe to the server. That's pretty good. Unlike any other options, like for turbo streams, we have to render specific subscription element before performing any updates. For live, we don't need to do that. So as I already said, and I already said about state and it's closer to LiveView. So that's a question, because I'm like working with ZD cable. I've found that one of the reasons why action cable applications requires a lot of memory when there are a lot of clients, that's because everything is kept within Ruby, all the state, and even if it's minimal state, it's too much for Ruby process. And we can cut it easily if we do not keep state in the Ruby. We need to think about something different. Like, for example, I forgot to mention, like that was on the slide, maybe someone noticed it, but stimulus reflex send data attributes along every reflex action of the element. So the state is not kept on the server, but it's transmitted with every action, just we can use it. So there is a state, but it's kept on the client and resent with every request. That increases the payload size, but I think that's actually the less of evil than the process side. But it depends on the kind of application. If you have a lot of updates and a lot of communication, it's probably better to keep state like cached to the server. But if there are not so many updates, it's better to not store something that is used not so often in memory. So we coming to an end. Some summary of this. We discussed multiple technologies, more in depth. We discussed only 3 of them, 2 of them just mentioned, but even 3 different ways of doing the same is pretty like a lot, and 2 great libraries for Ruby. That's cool. And if you want to try this approach, I would recommend actually taking a look at the stimulus on CableReady. Hotwire, well, there is a problem with Hotwire. which is related to the Basecamp drama. I don't want to talk about it, but I don't know. We still haven't seen the release of final release of version 7, because currently it's beta something. I'm not sure that all the bugs was fixed in the final release. And what's going to be next? I'm pretty sure that's going to be fine, but that would probably take some time to get to the final release, to get the release with less bugs. Because when I tried Hotwire first, just a couple months ago, I found a very annoying bug when every element, every stream subscription created a new action cable connection, not a subscription, but a connection. So like an easiest way to solve the DOS, like just create 100 connections from each page of every client and you're done. So it has been fixed, but who knows what's left. So like I would say like Hotwire is cool, but at least its WebSocket part probably requires some attention and caution. So other two, I would say they are still promising, because like they're younger, they're less users, but they carry different ideas. The idea, I like component-driven approach more than like do whatever you want, but you should probably wait for some, big release or whatever from them. So to prove that they're ready, or you can join the team and help them to build it. Oh, hey.
This is Marco. Hi.
Hey, Marco. So what I think about all this approach is that that's the only way we can bring full stack development back if we want to. Because, well, me personally, I don't like all this SPAs, especially React driven, with a lot of code you don't understand why you need so much code just to render a page. So I miss that days of good old Rails stuff. And unfortunately, 5 years ago, I stopped doing front end at all. So, and I kind of still, my front end experience is from the good days. And now I'm coming back to it. And this is the way of which I would prefer to use. So, and it definitely worth considering for particular use cases where you don't need to overcomplicate with front-end stack, or you don't want to hire the whole new team. So like for small projects with like a couple of people, like an early stage, that's a way to go. Like to not waste your money on hiring cool React engineers, and instead to invest them in something better, which is more crucial for the early days startups. Or if you don't need cool interactions, or if your interactions, like every most of clicks or whatever, are coupled with server. Like if your front end app, written whatever it is, anyway performs an HTTP request to update, to handle user interactions, it doesn't make sense to like duplicate the logic of the both sides. You can serve HTML right away. But if your front-end app is like, online drawing app or editor or whatever, something that keeps a lot of state front-end at the front-end side locally, which is not duplicated on the server, of course, HTML-over-WebSockets is an overhead. Another use case I found very interesting for this kind of for this approach is making old apps, legacy apps, a bit better, vitalizing them with this stack instead of rewriting everything into front-end framework. So for example, there are a lot of applications, pretty mature applications using classic Rails with rendering HTML, partials, even JavaScript templates. And that's where you would like to consider replacing some of this with new stuff, with WebSockets. Especially like if you use JavaScript templates, say easily replaceable with streams and frames and whatever. So, or CableReady, even better. So that's a way to get rid of this legacy, but not to dive into the whole new stack for the front-end side. Final note, there's a link to the Discord server I mentioned, which is a great starting point if you want to discuss this kind of technology with a lot of Rubies and see how much is happening in this place. Actually, there is always questions, answers, discussions. So, and you can find me and my company on Twitter, GitHub, and whatever. Thank you for the great morning.
Okay, cool. Thank you. Thank you. Thank you so much.
Thank you.